Okay, in this question two is third last, third last. We're going to analyze two variables together, and the two variables happen to be categorical variables. And to analyze categorical variables, two of them, you want to use a pivot table. The two variables are status of the employee, promoted, not promoted. That's like a categorical variable. There are 104 observations here, and those 104 observations in status fall under either promoted category or the not promoted category. That's what's called categorical. It can also be called a qualitative variable. Ethnicity is the same. Well, not the same, but it's a categorical variable where the 104 observations can take one of two qualities or can be in one of two categories, not Hispanic or Hispanic. And when you're looking at the raw data, it's kind of hard to make conclusions. So what we're going to do is we're going to copy this data into Excel. I'm copying the data in the table plus stuff outside the table. I'm going to put that in, I'm going to move my cursor above A1, right click, and I'm going to paste special, and I'm going to choose match distance and formatting. Then I'm going to click the whole, I'm going to click the corner here. I'm going to change the alignment to left. I'm also going to change the any numbers to 4 decimal places. After I do that, I'm going to change this back to 1 decimal. So all future numbers will be on the left, and they'll have 4 decimal places, except these numbers. These numbers aren't really numbers. They're standing for employee names. Obviously, you can't have employee names due to privacy concerns, right? So I'm going to widen this out a little bit, and I got my two variables. I got my employee numbers, and then I'm going to click once on cell A1. I'm going to hold down the Shift button to grab all the data in this table. I'm not going to highlight submit question two. I'm going to get the data, right? And the label. So I got the data and the label. And then we go to insert. I'm going to choose, if you have Excel Maximize, you see the full ribbon. I click on insert. I get the option of pivot table on the left. I'll click on that. And then I'm going to choose from table range. And that, making that choice with the table already highlighted, populates this field with A1 to field 105, right? That's the labels and the data, not this junk down here. I'm going to put the pivot table in the existing worksheet right here at E1. Let me hit OK. All right, now for the pivot table, what do I want in the rows? I want ethnicity in the rows, and I want status in the columns. So over here, I'm going to move status to the columns, ethnicity to the rows. And then the thing is, if I drag employee to values, because employee is employee number instead of employee name, the default is to sum. And that is bad because the first employee gets a weight of 1, the last employee county gets a weight of 104. So again, these numbers are meaningless. They're standing for names, and you want some a set of names, right? So I can do one of two things. I can change the value field settings and click on count, right? Or, and I get the count. Or I could have done this. I could have just dragged in status and ethnicity down here. I noticed because status is categorical, it does count. Right? I could have done ethnicity and I would have gotten a count, right? So if I drag employee down, this has to count of employees. Or I can just drag in status ethnicity. You want to make that point. Employee is not a variable. Those numbers are meaningless. You do not want to sum them. Okay. Now, I don't want to work with values in a pivot table. So I'm going to copy this whole table. I'm going to paste it down here, a value. And then I'm going to think of it different. That's weird. I thought it was that would have less justified copy. I want to make 3 copies of it. And let's see exactly why that is. I'm going to get rid of these numbers. And then I'm going to get rid of the grand total on that table, the grand total column on that table. I'm going to get rid of the grand total in this middle table. Then I have a grand total on this bottom one, a grand total row. I'm not going to have a grand total row in this table, but I'm going to have a grand total column. I'm getting that. Then up here, I'm going to get rid of those 2. So in this table, I have a grand total and a grand total. You have to do this. And this right here is just a copy of the pivot table I produced, right? I'll show you why you want to make a copy of this. I want to make a copy of this right here, right? I'll show you why. Down here, I got the joint probability table. And this comprises 3 probability distributions that I'm going to put in box. The reason why it's called a joint probability table because the values inside this box are joint probability or intersection probability and probability. And the way you calculate them is you type equal, you come up here, and you divide by 104. Okay, what that means is the way you interpret this number right here, the way you interpret that number is this. The probability that a random, because there's 104 employees, right? So we're divided by 104. So we've got 104 employees in this company, right? Some are Hispanic, some are promoted, some are not promoted, some are not Hispanic, right? We've got 104 employees in this company. We're dividing all these numbers by 104. What that means is the way you interpret this is, of the 104 employees, right? Or randomly selecting one of those 104 employees, the probability that that employee is Hispanic and not promoted is 0.4327, right? To calculate this probability, you take the number of employees that are promoted and Hispanic and divide that by the number of employees. Okay, so this is the probability that a randomly selected employee will be Hispanic and promoted. This is the probability. So we want to calculate this probability. We take the number of employees that are not Hispanic and not promoted and divide by the number of employees in the company. And then to calculate this number, we take the number of employees in the company that are not Hispanic and promoted. And we divide that by 104. Notice when you sum these, you get 1. When I sum these 4 probabilities, I get 1. What that means is this right here is a probability distribution. We got 4 outcomes: Hispanic and not promoted, not Hispanic and not promoted, Hispanic, promoted. not Hispanic, promoted. Right? We have a 4-event probability distribution. Right? Now, in the margins of this table, I'm going to calculate the marginal probabilities. They're called marginal probabilities because they're in the margin of the table. This is the number of Hispanics at the company, and that's the number of employees at the company. So this ends up being the probability of being Hispanic at the company, 0.5577. This right here, if I take the 46 non-Hispanics at the company and divide by the 104, I get the probability of not being Hispanic at the company. Now notice if I drag this over here and I sum these two values, I get 1. So this is a probability distribution with 2 events, Hispanic, not Hispanic. And those 2 probabilities add up to 1. I'm going to calculate another set of marginal probabilities by using a lower margin of the table. I'm going to take the number of people at the company who are promoted, number of employees promoted, and divide that by the number of employees at the company. And this gives the probability of being promoted, not being promoted at the company. Right? And I'm going to take this 21. This is the number of employees promoted at the company. I'm going to divide that by the total number of employees. So again, this is a probability distribution because it has 2 events, and those events, the probability of those events add up to 1. So I got a 3 for 1 here, right? 3 for 1. Okay, now let's see if we're doing this right. Let me freeze this and throw in a data over here. So, summary statistics, frequency for these. Just a little bit more. Okay, so these are frequencies. 45 employees at the company are Hispanic, not promoted. Your numbers might differ. 13 employees at the company are Hispanic and promoted. 58 employees at the company are Hispanic. 38 of the employees are not Hispanic and not promoted. 8 of the employees are not Hispanic and promoted. 46 employees at the company are not Hispanic. 83 employees at the company were not promoted. 21 employees at the company were promoted. And there are 104 employees at the company. We'll hit enter to see if we got it right. And we did. Right? We got it right. Now we're going to film the joint probability table. Right? The probability an employee at the company is not promoted in Hispanic is 0.4327. The probability that a randomly chosen company or employee at the company is promoted and Hispanic is 0.125. The probability, let me complete this. The probability that a randomly chosen employee at the company is not Hispanic and not promoted is 0.3654. The probability that a randomly chosen employee at the company is not Hispanic and promoted is 0.079. I'm going to enter to make sure that joint probability distribution, those are correct probability values. Okay, so that, and they all equal 1, right? The sum of these 4 equals 1. Now I'm going to work on the second probability distribution in this problem. The probability that the employee is Hispanic is 0.5577. The probability that that randomly chosen employee is not Hispanic is 0.4423. I'll hit enter to verify 0%. Okay, and those two numbers themselves represent the outcomes of a unique probability distribution with two outcomes: Hispanic, not Hispanic. All right, what about the other marginal probability distribution? Not promoted, promoted. The randomly chosen employee at the company that is not promoted is 0.7981. The probability that a randomly chosen employee at the company is promoted is 0.02019. And those two numbers comprise the probability which has two events, not promoted and promoted. And then the sum of each of the three is the sum of each of the three distributions, 3 2 out of the 1, 3 4 out of the 1, and then 3 2 out of the 1 is 1, right? Okay. Now we need to do the conditional probability. In the conditional probability, this right here is the probability of not being promoted at the company given you're Hispanic. And why do I say that? Well, we have a total over here, right? And when you have the total when you have a total, a column of totals, what you're doing is you're conditioning the probabilities on that category and then on that category, right? So if you will, we're going to ignore these values here. We're going to ignore those values. We're going to only look at, in this table, we're only going to look at Hispanic employees. Okay? So we blacked out all other employees, and we're only looking at the Hispanic employees. So given that you're Hispanic, right? Given that the employee is a Hispanic employee, what's the probability of not being promoted? Well, how many Hispanics were not promoted? 45. How many Hispanics were at the company? 58. Okay? So the probability of not being promoted given you are Hispanic is 0.7759. And that's different than this value here, right? It's different. Okay, so we're only looking at Hispanic, whether they're promoted or not promoted. The probability of being promoted given you're Hispanic, that's 13 divided by 58, that's equal 0.2241. Now notice that the sum equals 1. We have another probability distribution in here, right? We have another probability distribution in here. Okay. We have one probability distribution in here, 2, 3, and 4. This is like a 4 for 1 so far, right? Now down here, we want to ignore the fact that the person is Hispanic. We're going to black out that. I need to unblack out. So I need to delete fill here. Now we're only looking at non-Hispanic and their probability of being not promoted and promoted. So the probability that the probability of being not promoted, given you're not Hispanic, is this value. Okay. The probability of being promoted, 8 non-Hispanics are promoted, given that you're not Hispanic, is 46. Okay. And these sum 1. These two sum to 1. We have another probability distribution in here. Right? Another probability. Okay, the final set of let's go ahead and see if you got them right. So the probability of not being promoted given you Hispanic is 0.7759. The probability of being promoted given you Hispanic is 0.2241. And the total is 1.0000. Now these should be correct, and we are. Right? So that so one pivot table gives us not one before, not two, not three, not four, but five probability distributions, right? It actually gives us even more. It gives us a total of 7 companies. Okay, now on this one here, we're looking at the probability of not being promoted given you're not Hispanic, 0.8261. And then we have the probability of being promoted given you're not Hispanic, 0.1731. And those two add up to 1.0000. Okay, now we have we have two more probability distributions. We have the conditional probability of given that you're not promoted, and then you have the set given that you're promoted. Right? So for here, we're going to ignore, let me undo blackout. And we're going to black out everything but not promoted. So now we're going to ignore everything but not promoted, right? So there were 45 Hispanics who were not promoted. And in the company, there were 83 people not promoted. We're going to calculate these two probabilities, Hispanic and not Hispanic, given the number of employees who were not promoted. Okay. So the number of Hispanic employees not promoted is 45. We're going to divide that by the number of employees at the company not promoted. And then the number of people not promoted and not Hispanic was 38. We're going to divide that by the number of people who are not promoted at that company. Okay. And notice that these two add up to 1. These two add up to 1, so these two comprise a probability distribution, right? It's a probability distribution. Okay. So the probability of being Hispanic, given you're not promoted, is 0.5422. The probability of being not Hispanic, given you're not promoted, is 0.4578. And those two add up to 1.0000. Okay. So that's our 6th probability distribution. Now we're going to do our 7th. Okay. So here we have the number. We want to calculate the probability of being Hispanic given promoted. We're going to go up here and get the number of. Oops, let me black that. Hit the black out. Okay. Get rid of the blackout. Still. Now you don't have to black this stuff out. And then I'll black out. Now we're going to ignore everything but promoted, right? There were 13 Hispanics that were promoted, and there's a total of 21 people who were promoted. Right? So so the probability of being Hispanic given you're promoted is 13 divided by 21. The probability of being not Hispanic given you were promoted is 0.3810. I noticed that these two add up to 1. So this comprises the 7th probability distribution that we can create from this one pivot table. 0.6190 and 0.3810. And those two add up to 1.0. Okay, so we got green check mark here. That's great. Now, how many employees are promoted? We have to black out the table. Okay, how many employees are promoted? There are 21 employees, right? 13 are Hispanic, 8 are not Hispanic, and 21 are promoted. How many employees are not Hispanic? Well, 38 non-Hispanics are not promoted, and 8 non-Hispanics are promoted, and the total number of not Hispanics is 46. How many employees are not Hispanic and are promoted? Not Hispanic and are promoted. 8, right? Not Hispanic and promoted. 8. How many employees are Hispanic and are not promoted? How many are Hispanic and are not promoted? So this is Hispanic, not promoted, 45. Okay. Now, since the probability of an employee being promoted, the probability of an employee being promoted, which is the probability of being promoted, that's the probability of being promoted, right? Because we have 21 employees that were promoted divided by 104 employees. That's the probability of being promoted. Since the probability of an employee being promoted is equals 0.269, and the probability of an employee being promoted given, we want to look at the probability of being promoted. This is the probability of being promoted given what? Hispanic. This is the probability of being promoted given not Hispanic. So you want to know the probability of an employee being promoted given that they are Hispanic. Promoted given they are Hispanic. So that would be this value. Okay. All right, cool. We got everything right. Now notice they're close. They're not equal, but they are close, right? These two values right here are equal. If they were both 2019, like this up here, if both of these were equal to that, then you can conclude that um, ethnicity and promotion status are independent events. But because this one's above that, this one's below that. You can think of this as the average of these two. It's actually a weighted average, right? But this number is between these two because this is the probability of promoted. This is the probability of promoted given you're Hispanic, and this is the probability of being promoted given you're not Hispanic. It's not surprising they're close to the probability of being promoted, but they are not equal to the probability of promoted. All three of these things in yellow all three of those are the probabilities of being promoted. Once the probability that a randomly chosen employee is promoted, this is the probability of being promoted given that you're Hispanic, and this is the probability of being promoted given that you are not Hispanic, right? And this one's above, they're kind of like the average, and this one's below the average, right? They're different, right? Now, when these probabilities are different, the two events are said to be dependent events. Okay, they're when these probabilities are different, the events are dependent. Different, different, the events are dependent. Okay, let's double check that we got that right. So far, so good. So Hispanic and promoted are what? What are we going to conclude about Hispanic and promoted? Are they non-mutually exclusive events? Are they mutually exclusive events? Mutually exclusive events are events like that have an intersection probability of 0, right? Uh, that's the definition of mutually exclusive events, right? Is that uh, there's nothing in the intersection. But we can see over here, we can see right here, um, Hispanic and promoted. There are 13 people who are Hispanic and promoted. There are 13 items in the intersection of Hispanic and promoted. So they're not mutually exclusive events, non-mutually exclusive, right? Non-mutually. Because there's something in the intersection, right? Now, what about Hispanic and not Hispanic, right? Well, in this particular case, you're either Hispanic or you're not Hispanic, right? So there's zero people in that intersection because you're either Hispanic or you're not Hispanic, right? So these are mutual exclusive. Okay. Okay. And that's it. So in this problem, we concluded that race or ethnicity and promotion status are dependent events. Now, you could now at this point you might conclude discrimination. Um, so this is just saying you might have discrimination. What happens? What has to happen now is you have to do a further dive into the data. Right? It could be the case that um, the reason why Hispanic right here, Hispanics promoted at a higher rate than non-Hispanics. It could be the case that um, this company stays in Mexico in a coastal town where you have a lot of and there's universities in this town. You can have a high number of employees with lots of experience and education. And because it's a coastal town, maybe it attracts uh, non-Hispanics from America who like to surf. And maybe the surfers, maybe, I'm not saying all, but maybe the surfers, they tend not to go to college or are more interested in catching the waves than catching a promotion. So that could be the case, right? Or it could be that the company just prefers to hire Hispanic employees in Mexico because maybe the customers are Hispanic. So there's a lot of reasons for um, the higher promotion rate of Hispanic. It could be a Hispanic-owned company, right? But there is a difference in a later chapter of the book. We're going to do a chi-square test, statistical test, and in the statistical test, right now, if there's a difference, you can include dependent, right? Race, ethnicity, and promotion in this model. One depends on the other. Right? In a future chapter, when we do a chi-square test, if uh, that difference has to be significant. So it could be the case that these differences are statistically insignificant from the related average. It could be so in that future chapter, it has to be a large enough distance or difference for you to conclude dependency. For now, though, them not equaling suggests a dependency. Right? All right, that's it for this question.